Good morning, audience, and welcome to this morning's class. Today, we have come again to continue to make efforts to solving problems that are both logarithm and indices related. A lot of classes we have had on these concepts have met appreciation by our listeners. So, therefore, we continue to make efforts so that at the end, students who are our listeners will not have challenges about these subject matters. Today, we just have few questions that we are going to solve with you that connects both indices and logarithm. So most of our videos in YouTube, you are going to see them tagged relationship between logarithms and indices, or indices and what and logarithm, or links between indices and what and logarithm. You'll be seeing concepts like this. We just have very small thing this morning to call up on the board and solve with you. But then I assure you, you are not going to remain the same after solving that problem. Thank you very much. That question says, and I write, call it question number 1. That question says, if a raised to power x equals b raised to power what? Y. Then log a all over log b equals what? Very simple, demanding question, which a smart student or which a student with the idea of indices and logarithm can quickly arrive at the answer. So as a way of solution, what I'm going to do. So I have said, permit me to divide this board this way. So I have solution. What I'm giving is what? A raised to power x equals b raised to power y. Remember in mathematics that if you use the same quantity to multiply what you have at the left and what you have at the right, you have not changed anything in the system of that equation. If you subtract the same quantity at the left and subtract the same quantity at the right, you have not changed the system of that equation. If you add the same quantity and add the same quantity, you have not done anything. So what I'm going to do this morning is to use the same quantity to multiply the what to the left and multiply the what to the right. And the choice of that quantity, because I am looking at something in log, is to use log to multiply the left and equally use the log to multiply the right. Because the question they ask me is tailoring towards a logarithm. So effort should be to convert these indices now into logarithm. That's the reason why I normally say that you must have to have at the tips of your fingers the laws or the connections between indices and the logarithms. So I'll come here, what I'm going to have here become, using the log to multiply this side now, I'm going to have log, so a raised to power x equals log b raised to power what? X. So what I have done here now is to use log and multiply left and multiply right. Remember that law in logarithm that says that when a log of a number is raised to a power, that we use that power to multiply the what? The log. That is a law in logarithm. That whenever a number, that number is this a, is raised to a power, that power is x, that we are free to write that expression as using that power, which is the x, to multiply the log of that number. So this thing I have at the left hand side can be written as what? X times log of what? Of a. That's what they are saying. This equals. It is also the same here. This number b is raised to a power what? Y. Sorry, is raised to a power what? Y. So I'm now going to say that this thing becomes y multiplied by log of what? Of b. And if I have some, of course, this thing becomes what? What we have x log what? A equals y log what? Log b. Okay. In ratio, if you want to convert something of this kind in ratio, you understand? Where you are going to talk about, in fact, the rule there is you have two things multiplying each other here at the left hand side, you have two things multiplying each other at the right hand side. So if you want to convert them to what? To ratio, if you take this first one all over the second one, if you take the first from the what? The left, all over what? The first from the right, you are now going to take, is going to be equated to, you take the second from the right all over the second from the what? From the left. So, but the question I am asked is what? Log A. So, meaning that I'm going to come here now and take first this log A, this second one now. So, I'll say, therefore, this my log A all over. The second here is what? Is log B all over what? Log B. This equals. Because I started taking here first, I must come and take this place. So I'm now going to say this equals what? Y all over. What I have here is what? Is x. So the value of log A all over log B is what? Y all over what? All over x. So they can decide to say where at the end the true value of y is this and x is this. It's on that ground that you can make a substitution here and then you quickly arrive at your answer. You see how this thing is very, very simple to do. So they give you that kind of a thing, then that's how you now navigate your way out of that kind of a problem. Thank you very much for being our audience this morning. We appreciate you. Remember to subscribe to our YouTube channel as we continue to make effort to solve these kind of problems with you and then make your confidence on mathematics very high.